Hi, everyone. Welcome back to another episode of Unscripted Coding. As you can see, we have LeetCode in front of us. It's a site with a lot of algorithmic problems, database, whatever other problems, programming challenges, basically, for us to solve. Last time, I tried to do a hard one on screen, and I got relatively close, but failed on a few test cases. So today I thought we'd do a shorter one. We'd go for a medium difficulty problem, and hopefully this time I will do well. So I am just going to go and pick a page further down. You'll see I haven't done any of these really. And I'm going to pick one with a solution and relatively high success rate. I think I saw a 65 here. Let's go with this one, single number 3. I am obviously scaling back my ambitions. Let's keep it short. Let's actually successfully do this rather than watch me muddle about for a long while. Okay, so let's zoom in so you guys can read along with me. Single number 3. Given an integer array nums, in which exactly 2 elements appear only once and all the other elements appear exactly twice, find the 2 elements that appear only once. You can return the answer in any order. You must write an algorithm that runs in linear runtime complexity and uses only constant extra space. That's very interesting. So let's just look through this. You have an array, a list of numbers. You have 2 elements that show up only once, and you have a bunch of other elements that appear twice. So the really simple way to do this, I think, is just run a loop. Go through every number and search and see if it shows up more than once. That is not going to run in linear runtime. Linear runtime, I don't know if I'm the best person to explain it, but it runs more efficiently. If you run, say, exponentially, it just grows higher and higher. The longer the list, you get super complex because you're not just increasing the amount of lists, you are increasing the amount every element interacts with every element in that exponential case. Linear runtime, this is what makes it, I guess, a medium problem, but I think this is the part where it makes it a little more difficult. So let's just look at their examples really quickly. This is the first list. This is the nums. You see 1, 1, 2, 2. Those are things that appear more than once. And then 3 and 5 only appear once. So 3, 5 is valid. 5, 3 is valid. If you look at examples 2 and 3, okay. So negatives are possible. 0 is possible. I think they were all integers. Yep, integers. So there's no fractions, no decimals. But these 2 are simple. There's only 2 elements, so the answer are the 2 elements. Okay, so linear runtime means we shouldn't be comparing the elements against all the other elements. That will just increase the complexity. Linear to me means we gotta look at each element and make a decision then. Every time you get an element, that's it. And I'm going to do this on Code Sculptor because I think it's just easier to run and see the output side by side. And I am going to this as an example. Solution equals solution dot single number And I think I go print the statement. Oh, I have to have an input. Okay. So that's just how I can check. As I said, I think the trick here is for I in nums, and we're going to do various things to it. And then we're going to return. I am going to create a list up here called output, and we'll return output. Okay, so I actually think this, and I might be oversimplifying this, but I think this is going to be really, really easy. We are going to take the first element, and we are going to put it into output. We're going to look at the next element. If it's a different one, we're going to put it into output. If there's a third element and it's different, we're going to put it into output. If it's the same, we got to take it out of output. Does that make sense? So we have a list here. 1, we put it into the output array. 2, we put it into the output array. 1, not only do we not put it into the output array, we remove it outwards. Okay, so for I in nums, if I in output put dot pop Python pop. Yeah. Pop is okay. Remove from list. Yeah. Remove I. Else output dot append I. Let's see if that works. 3.5. Okay. Let's try this. It's not that simple, is it? Let's just submit and see what happens here. Or let's run the code first. As accepted. Let's submit and see. My worry is that constant space. Oh, success. See, that went so much easier than the hard one, didn't it? So runtime, it is faster than 12.57% of Python 3 online submissions. Memory usage, less than 97%. So that's really cool as well. So let's go back to the description first. They have 2 really important limitations here. One is linear runtime complexity. The best way to say this is we should only have one loop that goes across that nums list. If it's 100 elements, it should just run 100 elements times. You should not be doing another loop inside this loop. So we can't go for I in nums and then for Z in nums and we compare the two, or some other weird way you want to do this so that for 10 elements you suddenly do 20 or 100 or 1,000 different combinations. For us, we are just going through once. If it increases, if this doubles in size, linear means that the complexity only doubles. It doesn't exponentially grow. The other major limitation is constant extra space. And I'm not quite sure what they mean by constant extra space, but my initial assumption was that we were going to fail the submission because output can grow and shorten depending on the size. And I think the easiest way to do this is output is fixed to 2 elements. And I'd have to find a way to remove the first elements here. But the output should never be larger than 2. There's only 2 elements, and then when there's a third, once we get to the third one, we know that it has to replace something in there. So I'm surprised that this didn't trigger anything. But what's really cool is they give you a bit of stats. In runtime, I did horribly. I am slower than 87% of people, meaning that this is one of the slower submissions. And I think it's because I'm doing a check for each element. Is there a better way? Actually, I think the better way is not to have a check at all. You would just see the length of output. You can probably save some room. Just set the length of output. For the first 2 elements, you're not even going to do anything. You don't need to check for the first 2 elements, because they're just going to be automatically lodged into output, unless the second element is the same as the first element. But you can kind of shortcut your way in there, and then you can make a comparison quicker. You wouldn't need to do those first 2 elements. So I think there are ways to optimize this, but I really, I think we're quibbling with peanuts here. This is not complex at all. And then memory usage, we beat out 97% of people, because this output is going to be 2 elements. Another way I think you could have done it is you could have just slowly removed outwards. So you could have taken something like 10 elements and slowly picked it off. But we will never get over 2 elements inside the output. Okay, so I'm going to stop rambling. This was super simple, and I am so happy that we were able to do this much quicker than the hard one that I failed to solve. Okay, so if you like this video, I think it's a lot of fun for us to do a couple of these algorithmic ones to walk through it, rather than building just UIs, building projects all the time, because sometimes you do need to go back to the basics. You need to get your math sorted out. So I thought that was a lot of fun. So if you liked it, please give me a thumbs up, subscribe, please just comment if you have any constructive feedback. But I'd love to hear from you, what other kind of videos you'd like to see. We have done all sorts of things, from electronics to tiny projects to now algorithms. And I'd love to see what you're actually interested in. So thanks for watching. Stay tuned for the next episode.